Data analytics, as we know today, is the process of examining the datasets and draw conclusions to make informed business decisions. It is also worth noting that the human civilization started to curate, interpret, and summarize data since early times in order to bring out the values and insights. Talking about the 20th century, statistician William Seeley Gossett, who was working in a brewery, applied his statistical knowledge to select the best yielding varieties of barley. All such types of statistical methods stayed with the mathematicians and statisticians till the mid-of-century. In the last few decades, software tools like Excel, SAS, and programming languages like R and Python have been making tremendous progress, enabling the data scientists of today's time to apply statistical algorithms using ready-made libraries and new algorithms. Let us talk about how the tools and software for data have evolved over the century. SAS was the earliest software to be developed for data analytics. The North Carolina University started working the project named Statistical Analysis System in 1966 and worked until 1976 when the SAS Institute got incorporated. SAS continued to grow and mature as a product, and in early 2000 they introduced several new tech areas like social media analytics. R language for data analytics wasn't developed from a software research lab, but rather from the need of statistic professors who need the technology for quick statistical computing. In 1991, statistical professors Ross Ihaka and Robert Gentleman from University of Auckland started working full-time to develop a language that could fulfill the much-needed technology for statisticians. They launched the first version of the R language in 1993. Since then, R has been in support and updated regularly. It is also one of the most widely used programming languages due to its open source contributed rich set of libraries. R is currently dominating the data science industry. Coming up to Microsoft Excel. As you already know that Microsoft Excel is a very common tool used by all types of industries, both small and medium companies, professionals and individuals for diversified purposes. In 2016, O'Reilly conducted a survey to find out which is the most common tool used by the data analysts. 70% of the respondents answered Excel, demonstrating the wide and deep usage of the tools for data analysis. Moving to Python, which is a general-purpose programming language created by the Dutch programmer Guido van Rossum. The first version of the language was released in 1991. Python libraries like NumPy and Pandas are the backbone for data science. Python is also used as a scientific scripting language to rectify the problems of numerical data processing and manipulation. As a part of Google Summer of Code Project 2005, David Conepo, a data scientist from Paris, started working on creating a machine learning library called scikit-learn for Python. The first version of the library was launched in 2007. Just over the last year or so, Python has started to become the first choice for data scientists, especially in the area of deep learning. Today, Python has been listed as the third most used programming language by social programming community GitHub. But what happens if you have really large data which is semi-structured or worse, unstructured? It can take hours and days to build and execute your tasks to finally get any results out of your efforts. All these requirements led to the birth of the big data. The growth of big data is divided into 5 dimensions known as the 5 V's of big data, which are volume, velocity, variety, veracity, and value. Let's take a look at each of these. The term volume is used in context with data size, which is moving swiftly from gigabyte to terabyte, petabyte, and so on. These volumes could not be stored and analyzed using traditional systems. Velocity refers to the speed at which the data is generated, stored, or processed. It can be calculated in per hour, per minute, or per second basis. Variety refers to the data that social media era has introduced in the form of unstructured data, be it text, images, videos that can be fit into the structured databases. The next V is veracity, means to identify the truth from all kind of information. The last V, that is value. Value is simply defined as the potential benefit of the data for the business. Now, let us talk about the technologies associated with big data. The big social media players have pioneered the technologies that can handle big data volumes. Hadoop framework, consisting of the file system HDFS and programming language MapReduce, is an open source software framework for storing and accessing big data. The technology has rapidly grown to make the power of data to the engineers in a friendlier manner. Pig scripting language and Hive, an SQL-like interface to query data, have made big data engineers be able to deliver business results at speed. The real-time analytics gave birth to several frameworks, and currently Apache Spark is leading the space to process real-time data with a powerful set of libraries including machine learning and graph processing. Data is the new gold or oil, and it is imperative that all the different business functions are able to access and discover data, understand and interpret it, apply statistical modeling, and fine-tune the method to gain the right level of insight and enable a truth-based decision-making. Hopefully, you have got a quick summary of the technology landscape that aids with data science.